According to the National Electrical Code, specifically Article 240.4b, the ampacity of electrical conductors must be determined by the maximum demand of the load they serve, not by the rating of the overcurrent protection device, such as a fuse or a circuit breaker. This means that even if a fuse with a lower amperage rating than the circuit breaker is installed in the circuit, the wire size must still be sufficient to handle the full potential load that the circuit breaker is rated for. The scenario describes a situation where a 70 amp load is connected to a 100 amp circuit breaker using a disconnect switch also rated for 100 amps or 70 amps, and the desire is to save on wiring costs by using wire sized for 70 amp fuse. However, this is not permissible under the NEC. The reason for this is that the circuit breaker is the primary overcurrent protection device for the circuit, and it is designed to protect the wiring from overloads and short circuits. If the wire is sized for only 70 amps, but the circuit breaker is rated for 100 amps, there is a risk that the wire could overheat and potentially cause a fire before the circuit breaker trips. The NEC requires that the wire be sized to match the rating of the circuit breaker to ensure that the wire is adequately protected. To elaborate, the code establishes minimum requirements for the safe installation of electrical wiring and equipment. These requirements are in place to protect people and property from electrical hazards. One of the most important aspects of electrical safety is ensuring that wires are properly sized for the amount of current they will be carrying. If a wire is too small for the current, it can overheat and potentially cause a fire. To prevent this, the NEC specifies the minimum wire size that can be used for different amperage ratings of circuit breakers and fuses. The size of a wire is measured in terms of its ampacity, which is the amount of current that the wire can safely carry. The ampacity of a wire depends on several factors, including the type of wire, its insulation, and the ambient temperature. The NEC provides tables that list the ampacities of different types of wires under various conditions. These tables can be used to determine the minimum wire size that is required for a particular application. In a specific scenario, the question explores whether it is permissible to size the wire based on a 70 amp fuse, given that a 100 amp breaker is already in place. The NEC clearly states that the wire size must be based on the overcurrent protection device, which in this case is the 100 amp breaker. Therefore, the wire must be sized to handle at least 100 amps, regardless of whether a 70 amp fuse is also used in the circuit. Attempting to reduce costs by using a smaller wire size would be a violation of the NEC and could create a dangerous situation. It is essential to always follow the NEC guidelines when installing electrical wiring and equipment. This will help to ensure that the installation is safe and compliant with applicable regulations. When dealing with electrical systems, safety should always be the top priority. Cutting corners on wire size can have serious consequences, including the risk of fire, electrical shock, and equipment damage. Therefore, it is important to always consult with a qualified electrician to ensure that electrical installations are done correctly and safely. The NEC provides detailed guidance on wire sizing, overcurrent protection, and other aspects of electrical safety. By following these guidelines, it is possible to create electrical systems that are both safe and reliable. Undersized wiring is a common cause of electrical fires. When a wire is forced to carry more current than it is designed for, it will overheat. This overheating can damage the insulation around the wire and potentially ignite nearby flammable materials. In addition to the risk of fire, undersized wiring can also cause other problems such as voltage drops and equipment malfunctions. Voltage drops can occur when the voltage at the end of a circuit is lower than the voltage at the beginning of the circuit. This can cause lights to dim, motors to run slower, and other equipment to malfunction. Therefore, it is important to ensure that wires are properly sized for the load they will be serving. If there is any doubt about the correct wire size, it is always best to consult with a qualified electrician. They will be able to assess the situation and recommend the appropriate wire size for the application. The NEC also addresses the use of fuses and circuit breakers in electrical systems. These devices are designed to protect wiring and equipment from overloads and short circuits. When an overload or short circuit occurs, the fuse or circuit breaker will trip, interrupting the flow of current and preventing damage to the system. It is important to select fuses and circuit breakers that are properly rated for the circuits they will be protecting. If a fuse or circuit breaker is too small, it will trip unnecessarily, causing inconvenience and potential downtime. If a fuse or circuit breaker is too large, it may not trip quickly enough to protect the wiring and equipment from damage. The NEC provides guidance on selecting the appropriate fuses and circuit breakers for different applications. This guidance should be followed carefully to ensure that the electrical system is properly protected. In addition to wire sizing and overcurrent protection, the NEC also covers other aspects of electrical safety, such as grounding, bonding, and wiring methods. Grounding is the process of connecting electrical equipment to the earth. This helps to protect people from electrical shock by providing a low resistance path for fault current to flow back to the source. Bonding is the process of connecting different metal parts of an electrical system together. This helps to ensure that all of the metal parts are at the same potential, which reduces the risk of electrical shock. Wiring methods refer to the ways in which electrical wires are installed and protected. The NEC specifies different wiring methods for different types of installations. These wiring methods are designed to protect the wires from damage and to prevent electrical hazards. Overall, the NEC is a comprehensive set of rules and regulations that govern the safe installation of electrical wiring and equipment. By following the NEC guidelines, it is possible to create electrical systems that are both safe and reliable. It is important to note that the NEC is constantly being updated to reflect new technologies and best practices. Therefore, it is important to stay up to date on the latest edition of the NEC. The National Fire Protection Association, or NFPA, publishes the NEC every 3 years. The NFPA also offers training and certification programs for electricians and other electrical professionals. These programs can help to ensure that electrical professionals are knowledgeable about the NEC and are able to install electrical systems safely and correctly. When working with electrical systems, it is always important to follow safe work practices. This includes wearing appropriate personal protective equipment such as gloves and safety glasses, and using tools that are in good condition. It is also important to energize circuits before working on them. This can be done by turning off the circuit breaker or removing the fuse that supplies power to the circuit. Before de-energizing a circuit, it is important to verify that the circuit is actually de-energized. This can be done using a voltage tester. A voltage tester will indicate whether there is any voltage present in the circuit. If there is voltage present, the circuit should not be worked on until it has been de-energized. When working on electrical systems, it is important to be aware of the potential hazards. These hazards include electrical shock, arc flash, and explosions. Electrical shock can occur when a person comes into contact with a live electrical conductor. Arc flash is a sudden release of electrical energy that can cause severe burns. Explosions can occur when flammable materials are ignited by an electrical spark. To prevent these hazards, it is important to follow safe work practices and to use appropriate personal protective equipment. In conclusion, the NEC is a critical resource for ensuring electrical safety. By following the NEC guidelines, it is possible to create electrical systems that are both safe and reliable. It is important to stay up to date on the latest edition of the NEC and to follow safe work practices when working with electrical systems. The information provided in the scenario highlights a common misunderstanding regarding wire sizing and overcurrent protection. It is essential to remember that the wire size must always be based on the rating of the overcurrent protection device, which is typically a circuit breaker, and on the load that it is expected to carry. While it may be tempting to save money by using smaller wire, this is a dangerous practice that can have serious consequences. Safety should always be the top priority when working with electrical systems. Remember, the question asks about sizing the wire based on a 70 amp fuse in a situation where a 100 amp breaker exists. You cannot do that. The wire must be sized appropriately to handle 100 amps. The potential for overheating and fire is substantial if you do not follow code. Always consult the NEC and a qualified electrician for any electrical work to ensure it is done safely and up to code. In the provided scenario, using wire sized for 70 amps would be a violation of NEC code and could pose a safety hazard due to the potential for overheating and fire, given the 100 amp breaker. Remember, the wire must safely handle the potential current flow allowed by the breaker.